Today I'm going to talk about most of the components that you'll see throughout your degree in electrical engineering. The first one I'd like to cover is the resistor. So the resistor will limit or regulate the current that you will receive. So resistors come in all shapes and different sizes. You will commonly see this form of a resistor, but there are variations like this. So you might be asking why, what's the point of this? And from my personal experience, it depends all upon how much current you're feeding through it because of things like heat transfer and your heat properties. So if you're sending a lot of current through this, it's going to get very hot very quick because of the small surface area compared to this. To notice with resistors is this color band on them. So what this is, this defines what the value of your resistor is. So here is a card that I was given that is kind of self-explanatory, and it will teach you what these bands mean and what values you're getting. The component we're going to look at is the capacitor. Now the capacitor kind of looks like a pancake with two legs. There are cylindrical capacitors, but I don't have any with me right now. And what these do, they hold charge. So when you apply a voltage, it'll charge it up, and then when you turn that voltage off, it'll dissipate current out of it. So these act different in an AC and a DC voltage applied, which we will see more when we start to go through circuit analysis. To look at an inductor. Now what an inductor is that it is a wire that is wound around in a circle that is connected to each side, and what this will do is it will store energy in the term of a magnetic field. Similar to the capacitor, this also acts differently depending whether you have an AC or a DC voltage applied. But once you start branching out, you'll get into things like transistors, diodes, and integrated circuits. Where I'm from, we just call these chips, the integrated circuits. So a transistor, it looks like this. It is a very, well, this one's rather large compared to what they are now. They're on the size of nanometer scale now. But we can see that there's three legs, and these will get plugged in, and these will act essentially sort of like a switch. There's BJT transistors and there's MOSFET transistors. They have distinct features which you can classify, but overall talking, we can just compare them and say that they're closely related. Now, everybody has probably seen an LED, or a light-emitting diode. So diodes, what they do is they allow current in one direction, and they don't allow it in the other direction going back. Unless you're talking about the case of a Zener diode, which has different properties. But with a diode, there's also, besides the light-emitting diode, there's just a regular diode, which doesn't emit light, but it does the same thing. Now we can start to talk about ICs, or chips, as I tend to call them. So a chip is pretty much, it looks like this. There can be more pins, the size can be bigger, they're very small now. This is an older model, but it's easier to pick up and show. So this one is essentially a set of logic gates, which you can kind of think as, for example, an AND gate. Both inputs have to be on to have an output on, hence the word AND. You need input 1 and input 2. So that's what this guy contains, and here he contains a few of them. And then we have a larger chip, which contains many of these logic gates, and we can use this for an application in microprocessors. So another chip is an amplifier. So we use this to either input a certain voltage amplify that voltage for an output. But we have restrictions on this. We can't just magically make any output and any gain that we want. I've covered most of the components that you'll be learning about in electrical engineering. We should talk about how you're actually going to build these circuits. So what you're going to use is a breadboard. So what this is, it allows for you to hook up a power supply and have the positive terminal and then the ground in this area. And then you'll press your components into here. So it's pretty straightforward. You'll just find where the holes line up and press down, and then you'll have connections through the bottom of the board where there's metal stripping. So this makes life very nice. You don't have to solder the wires together. You don't have to tie them together and hope it works. You'll have connections that are pretty safe. They're not just going to fall out. Another way that you might see components connected is through a PCB or a printed circuit board. So again, we can see most of the components. We have resistors, capacitors, some LEDs, some ICs, and then a few other things. So how these are connected is these actually are soldered to the board, and then through the back there are interconnects. You will have something that looks similar to this. It may be larger, it might be smaller, but what this is it is a power supply. So this, you'll be able to supply current and voltage to your breadboard or your PCB. So the voltages range differently depending what model you get of one of these, but your university will probably have 10 or 15 of these. Another thing that you will look at is an oscilloscope. Now, the ones that your university may have will probably be the size of a laptop or larger. This is a small one that I kind of use when I build little circuits for fun. So what this allows you to do is you will pick 2 points on your circuit, usually a ground and whatever you like to measure, and you're able to measure the signal. This is what I primarily use as an oscilloscope, but this also has a signal generator built into it that's it doesn't fit any need that I have for it. But what a signal generator is it's pretty straightforward. It generates a signal. So you can do a square wave where essentially you're on for a certain amount of time and you're off. Or you can do something like a sine wave where it's oscillatory. Or you can do, I think this one also has a ramp wave in it, or a sawtooth. People might refer to it as that. But what that is, it ramps up, off, ramps up, off, ramps up, off. So those are most of the things that you'll be using in a laboratory setting for most of your classes. Thank you very much for watching.